All right, so today we're going to start section 2.1, day 2, writing and graphing inequalities. So yesterday we saw some inequalities and how to create them. Today we're going to be focusing on graphing them as well. Every single inequality has infinite solutions. So like the Warner problem was the same thing we did yesterday. It says compare the following two inequalities, x is less than 5 and 5 is greater than x. What are some possible values for x? We could continue to list numbers that are values of x that would be a solution to this inequality. Like, give me an example. What's an example of a number that's less than 5? 3. Another example. 2. Give me a negative example.
-3.
Perfect. And we could just keep going. Any number that's less than 5 is going to be a solution to this inequality. So when we have inequalities, we actually have to graph the solutions. So today we're going to be learning about how to graph solutions. A graph is just basically a number line. And in previous years, I know that you've seen this before, maybe your teachers made you put specific numbers on there. I'm going to only allow you or only require you to put the endpoint. The endpoint is the number that's in the inequality. If you want to do one bigger than it, if you want to put 6 on there to the right and 4 to the left of it, that's fine. I know some teachers would make you put 0 on it, but it's honestly not necessary. You would only need the endpoint to show what the inequality is about. And then we're going to be learning that there's two types of circles that we would use to represent if the solution of the endpoint here is included or not. Since 5 is not included, since the inequality is less than 5, 5 is not less than 5. So the type of circle we would use in this case, which I'll go over more next, is an open circle. And then all of the solutions that are less than 5, are they to the left of 5 or to the right of 5? Left. All the numbers that would be less than 5 would be all these numbers here, because technically this is 4. And 3, and 2, and so on. So all of the solutions are to the left here. So here's how I graph my inequalities. You might graph a little bit differently. Maybe you choose to, on your number line, have your endpoint. Maybe you would choose to put the circle above it and then the line above it. That's fine too. Some choose to kind of do similar to me. Open circle, but then just like bulb the line out so it looks, I can see it, the arrow is going this way. There's just a couple different ways to graph. I don't mind which way you choose to do it, but the reason why we have to graph is there's infinite solutions to each inequality now. In equations, there's only one answer, x equals 5. So you don't have to graph a number line with 5 on it because it's just silly. But for inequalities, since the answers are infinite, anything less than 5, you would have to graph it and show that anything to the left of 5 would be a solution. So the official notes say the graph of an inequality shows the solution set of the inequality on a number line. An open circle is used when a number is not a solution. I used open circles for all of these examples for this inequality because the inequality is x is less than 5 and 5 is not a solution to this inequality. When it is a less than symbol or a greater than symbol, the solution is not one of the endpoints. So you would have to use an open circle for those. A closed circle is used when a number line is a solution. What inequality symbols would the solution be included? What two inequality symbols will we have included solutions? Hang on, everyone's sleeping, I think, here. I may be at home. Less than or equal to and greater than or equal to symbols will be used for closed circles because those are going to be included. The arrow shows that the graph continues in that direction. So I know that there's no spot for this on your notes, but I'm just going to write here. This is an open circle, and it's used for less than or greater than. And then I'm just going to try and squeeze it underneath of here. A closed circle used for less than or equal to or greater than or equal to. Please copy those down so you remember what type of circles to use for the inequalities that we're graphing. All right, so let me clear this and scroll down. Now let's get to some practice problems. So we have here some examples in words. We're then going to create an inequality with algebra, and then we're going to graph it. So it says x is less than 2. So you read that and you realize, okay, the algebra version for this would be x, a less than symbol, and then 2. For your graph, the only number I'm going to require you to put on there is the endpoint. The endpoint is the number in the inequality. In this case, it's 2. So you would put a 2 on your graph. I usually decide to put it in the middle. It's up to you where you like to put it, but I usually put it in the middle. If you would like to, you can include more numbers on here. If you wanted to include 1, 0, -1, -2. You want to include 3, 4, 5, 6. It really doesn't matter. I'm honestly only going to put 2. It's the easiest because it's only one number instead of putting multiple, but it's up to you. The type of circle we will use depends on if 2 is a solution or not. If it's a solution, we will color in the circle and it turns into a closed circle. If it's not a solution, you would leave it open and it would just be a not colored in circle. What type of circle will I use for the 2? Gabe? Yes. It's an open circle because 2 is not a solution since 2 is not less than 2. So it's not a solution to this inequality. And in what direction will I shade in the solutions? To the right of 2 or to the left? Molly? This way? Yes. To the left. Good. So if you want to just fold out your line that way, if you want to do like a little squiggly line, whatever you would like to do to show me that I know you know that the answers are to the left of 2. Okay, the next one says x is greater than 2. So all of these endpoints are all going to be 2. The graph is going to look a little bit different. What's the only difference in this graph than the first one? Gabe? Yes, the arrow's going to go the other way. We still need 2 on the graph. It's still an open circle because it's still not included. But now the arrow is going to go to the right because any answer that's greater than 2 will be to the right of it. Then we have x is less than or equal to 2. So now we will have x, a less than or equal to sign, and 2. So for this one, the circle is going to change. Whenever you have less than or equal to or greater than or equal to, you color in the circle. You shade it in because 2 is now a solution to this inequality. And the reason why is because the little equal to part of the symbol. If it's less than or equal to, that means that 2 is also a solution to this. And since it's less than, the answers are going to be going to the left again. So the only difference between the third one and the first one is the type of circle, because if you notice, this is a less than symbol, and this is just a less than or equal to symbol, which is then you color it in. And then the last one, x is greater than or equal to 2, the symbol just flips. It's still going to be a closed circle at 2 because it's still a solution. But now the answers, anything greater than or equal to 2 would be to the right. All right, we're going to do 2 more examples together, then I'm going to have you guys try 4 on your own. So this now says y is less than or equal to -3. It does not matter what variables used in the inequality. The only thing you're looking for is the endpoint. The endpoint is the number in the inequality. So on your graph, you're looking for -3, and then you decide if it's an open circle or if you should color it in. This one, since it's less than or equal to, would be a colored-in circle, a shaded circle at -3. These graphs are already numbered for you, which makes it even easier. All you need to do is just plot the point on there, but usually the graphs will not be provided. And in what direction would I shade the solutions for this one? Where are the numbers that are less than or equal to -3? Gabe? Yes. Okay, and then the last one. My brain does not understand when the number comes first. Like this says 2 is less than the numbers. That's confusing to me. I mean, I do know that the endpoint is 2, so I can make my circle there. And I do know it's going to be an open circle because it's a less than symbol in this case. And I know it's not going to be colored in because it doesn't have the equal to part. But I get very confused when I go to graph this. I know in the past maybe other teachers have taught you, like, look at the way that the direction is going for the symbol, and that's the way you would shade, and that sometimes works. But it doesn't work if the number comes first. So in this case, this says 2 is less than all of the numbers, and I don't know what direction it's going to go. Since it says less than, my mind wants me to go to the left, but it's actually not going to be to the left. I prefer to switch these around and put the x first and the 2 second, because it makes more sense for me to understand the inequalities when the variable comes first. But when I do that, I have to flip the sign as well because it needs to be going towards the same number. And since it was opening towards the x, it flips around and becomes a greater than. So the answers are actually not to the left, it's to the right. So I really suggest if you don't understand graphing when the number comes first, just like me, I don't understand it, it doesn't make sense to me, then please take the time to flip around the inequality so the variable comes first. When the variable comes first, it's a lot easier to understand because this says all of the numbers greater than 2. That makes sense to me. This says 2 is less than all of the other numbers. And I just get confused by that. If you do as well, then please just flip it around so the variable comes first. On the next page, there's 4 practice problems. What I want you guys to do is go ahead and try these 4. Some of them looks like we have some decimals, so estimate if you have to. And in a couple minutes, we'll go over them together as a group. All right, let's go over these answers. So the first one, x is greater than or equal to 3. So the endpoint is 3, so I know I need my circle around the 3. Since it's a greater than or equal to sign, it's going to be a shaded, colored in circle. Anything greater than or equal to it would be to the right. Number 2 is a decimal endpoint, and that's okay, but I also am just confused with the way it is with the number coming first, so I'm going to flip it around so it makes more sense to me. When I flip the x and the number, I have to flip the sign from greater than or equal to less than or equal to. The endpoint is 1.4, so that's going to be in between 1 and 2. It's going to be a little bit to the left of the middle between 1 and 2, since it's very close to 1.5. And then anything, it's a closed circle because it's included, and anything less than or equal to it would be to the left. Number 3, the endpoint is negative 5, so I know I need a circle around negative 5. It's a greater than symbol, so I know it's an open circle. Anything that's greater than it will be to the right of it. And then number 4 is another problem where I don't like the way that it's written because I personally prefer the variable to come first. So I switch it to be x and 6, and then I have to flip the sign as well. So I know that it's going to be an open circle at 6. This graph does not go far enough, so I'm just going to extend it, writing a 6 in there. An open circle at 6, and anything that's less than 6 would be to the left of it. Any questions on that? This is pretty easy stuff. If we flip this over to the next page, we have just some word problems that we're going to quickly go through. So modeling with mathematics. The graphs show the height requirements or height restrictions, h in inches, for 2 rides at an amusement park. Write an inequality that represents the height restrictions for each ride. So we have here inches for the height requirements. I see here for ride A, it starts at 48 and the answers are to the right. Can you be 48 inches to ride the roller coaster A? Yes, and you can be because it's a closed circle. So you could be 48 inches, you could be 48 and a half inches, 49 inches, anything bigger than or equal to 48. So using whatever variable you want, if you wanted to use h for height, if you wanted to use x, ride A would be, I'll use h for height. H is greater than or equal to 48 inches because you can be 48 inches since that circle is closed. How about ride B, though? What would the inequality be that represents ride B? Anybody here? Well, I'll use h again for height. I can see my end point is 52, so I can write 52 here. And then you just have to determine the symbol. So I can see the arrows pointing to the left. So because it's all the numbers to the left, it's either going to be less than or less than or equal to. And to determine what one of those two it will be, you look at the type of circle it is. Since 52 is not shaded in, what symbol does it have to be? Gabe?
Not the one with the line under it.
Right, so just this one here. Perfect. So the h is less than 52. So for the first ride, it must be a roller coaster where you have to be bigger than or equal to 48 inches, and then maybe ride B is like a smaller kid ride, and you have to be less than 52 inches to ride it. Okay. Letter B says, on a fishing trip, you catch 2 fish. The weight of the first fish is 1.2 pounds. The second fish weighs at least 0.5 pounds more than the first fish. Write an inequality that represents the possible weights of the second fish. Okay, so we have here the first fish is 1.2 pounds. The second fish weighs at least 0.5 pounds more than the first one. So if this second fish weighs 0.5 more pounds than the first one, and the first one's 1.2 pounds, what's the minimum weight of the second fish? What would you do to find that minimum weight, Molly? Yes. So the minimum weight is going to be 1.2 pounds plus the 0.5 pounds, so it's going to be 1.7 pounds. That's the minimum weight. However, the reason why they want an inequality is because the second fish doesn't have to be exactly 1.7 pounds. That's the minimum. So if we use F to represent fish, and I know that the minimum weight is going to be 1.7, what symbol would I need to show that the minimum weight is 1.7, but it can be anything above that as well? What symbol would I need there, Molly? Perfect. So it would be greater than or equal to. All right, and then the last one on this page is there are 430 people in a wave pool. The maximum capacity is 600. Write an inequality that represents how many more people can enter the pool. So they want us to write an inequality because not exactly this many people are going to be entering the pool. Up to a certain amount will enter the pool. So we know here there are already 430 people in there. The maximum is 600. What would we do to figure out how many more people can enter the pool? First thing, what would we do to figure that out? What operation would we use? Molly? Good. So we would do 600 minus 430. And we're going to get 170. Did I do that math right? And when we get that 170, that is going to represent how many people could enter the pool. That's the maximum. So what inequality, if I use P for people, and I know that the endpoint is what, 170, what inequality symbol would I use to represent that 170 is the maximum amount of people that can enter the pool, but it doesn't have to be exactly that. It could be anything under that as well. Gabe?
Less than or equal to?
Yes, less than or equal to. Great. Now, these word problems did not ask us to graph as well, but usually whenever you have an inequality answer, you will graph. So let me just show you, like if I didn't have a graph prepared for you, here's how you would graph your answer. You would just draw a number line, which is a line with arrows going both ways. And then you would put the endpoint. The only number I'm requiring you to put on there is the endpoint, which in this case is 170. And if you want to put more numbers, you can. You don't have to. And then you decide what type of circle you would like. This would be a closed circle because 170 is a solution since it's less than or equal to. And then anything to the left of it, I would bold my line out or squiggle a line to show it would go this way.